and we will hop into a couple of slides I've got prepared for you today. Really around this concept of clean room testing for AI agents. And while we'll be talking about AI agent development, this clean room testing analogy also applies to pretty much any software that you're developing in and out of the enterprise today. So in the realm of agent-based technologies, right? There's some simple agents out there that do a little bit of work, maybe built based on some best practices, but a lot of the enterprise style agents that we're seeing being developed by our customers and through various publications out there are really chaining together multiple APIs dynamically in order to achieve a result. And the problem with that is that a single bad response from any number, even one of those APIs in those chains can cause some catastrophic failures with the agents, right? So whether that agent makes a wrong decision based off of a bad API call, in the case of today's demonstration, where we'll be looking at an example travel booking agent, right? That could lead to some failed bookings or even just plain old confused users, right? As we encapsulate a lot of this complexity behind an agent workflow and really having users scratching their head when it doesn't behave the way they'd expect it to behave. Now, non-determinism is the enemy of testing, right? And with unit tests, we typically take a look at very small pieces of our code that we're developing and when we get into these agents, where even a simple agent, the one that we'll be looking at today, comprised of only about 150 lines of code, a lot of complexity in there built into that little bit of piece. So our unit tests might be testing only 150 lines of code, but a lot can go wrong when we're coupling that with the LLMs of the world today, like Anthropic and ChatGPT, OpenAI's variant, right? For example, here, I have an example, right? Did the agent, having found no direct flights when it queried a flight API, did it correctly decide to search again, this time including a layover, or maybe plus or minus 1 day of departure times? And when it did that, if it made that decision, did it also make sure to adjust the hotel availability for those new dates? And then ultimately still charge the card? Or did it somewhere along the line hallucinate, right? And basically thought it got a confirmation from one of these original dates and then maybe skipped the payment exactly and you show up to the airport and nothing's actually booked for you, right? When we're developing our agents against real APIs, just like when we're developing any application, enterprise application against APIs, right? We have real risk about going against both third-party and internal APIs. A lot of third parties, it might be cost. A lot of sandboxes that we're provided with for third parties might not necessarily emulate the state. So, a ticket being booked and then trying to cancel it a little bit later. We might be sharing sandboxes inside of internal API environments, upstream environments where we're stepping on each other's toes with data. We might be going against some rate limiting, right? Or even just unavailability of those APIs for us to take the number of iterations that we need to ensure that our agent that we're building handles not only the sunny day scenario, but also the numerous rainy day scenarios that a user can incur. So the answer to this is this clean room analogy, right? Where we can control every variable possible in our testing environment and really focus in on our agent core capabilities, right? And handling all of those edge cases so that we can instinctively or intuitively direct the LLM what to do with these various different types of failure and edge cases. So we can mock all those external dependencies, right? All of those upstream APIs we're consuming, as we'll see today, that'll be an airline ticketing API, a hotel booking API, a credit card API, and an email sending API. So we can mock all those things out. We can even mock out the LLMs themselves, right? Early on in our agent development process, we just want to work on everything in our own little clean room bubble, not consume tokens at a rapid pace, not have any of those hallucinations be introduced during our early stages of coding, and only start to introduce those variables of hallucinations and token cost, right? A little bit later after we get our core logic done. And then, of course, we want to be able to programmatically or at our own beck and call introduce all of those edge cases and rainy day scenarios, whether those are from the LLM itself with the hallucination when we want to hallucinate to make sure we can handle that appropriately, or in the concept of that we'll be talking about more today, those upstream APIs not behaving as we want. This response is coming back too slow, the payment fails, the flights just aren't available, and making sure that our agent-based logic will handle all of these scenarios appropriately and intuitively for the end users. And of course, when we're doing this, right, we're simply isolating what we are testing, right? So we've got no shared sandboxes. We don't have to worry about rotating API keys. We don't have to worry about those upstream APIs being flaky for us. We're really just concentrated on what we're working on in the moment. So as I was alluding to, we're going to be working with this agent. We call it the travel booking agent to demonstrate this today. It's roughly around 150 lines of Python code. It's built on top of Anthropic's API, agent building APIs. I'll show you in a moment how it basically defines a set of 4 different tools. Each one of these tools is a separate API, the flights API, the hotels API, the payments API, and the email API. But it's initially configured to just talk to mock representations of these. And in the traditional sense of most agents, this is a standard agent loop architecture where Claude will pick one of these tools that are available. It'll make the call against it. The result comes back, and then it'll loop around again and see, okay, what's the next tool I have to call until it has a nice finite answer for the original ask and returns that to the end user. So we'll first take a look at what this looks like in a sunny day scenario. So I'm going to switch screens over here, and we'll see that I have 4 mock APIs created for us today. We have the email, the payments, the hotel, and the flights APIs, all provisioned freshly this morning for us. And if we go back and we look into what this agent looks like, as I mentioned, it's a simple Python-based agent loop. So we can see in our travel booking agent that we are defining some tools. Again, those tools are those external APIs that are going to be called by this agent in order to accomplish what we need to do in this user story, such as searching for flights, searching for hotels, processing the payment for these pieces, and ultimately sending confirmation emails. And if we come down just a little bit further, a lot of documentation in here, we'll start to see where the core agent loop is, right? A lot of agents built, in this fashion, even if we're using one of the popular frameworks that are out there for building agents, ultimately under the hood, we're dealing with core agent loops, where we're going to have a while loop and we're going to continuously pick a tool, send a message, pick a tool, send a message until we've got a reason to stop that particular loop. And then we also have those services defined in another section here. This is where we have defined how do we interact with these upstream APIs. Okay, let's move on to the actual application. So here's our travel booking agent. Really, really simple demo application here for us. I'm going to go ahead and hit refresh here. We'll get a prompt and we say, I need to get to Sydney for a trip. I want to fly on LHR to or fly from LHR to Sydney around this date and then return from Sydney, on another particular date here. And let's take a look at the sunny day scenario. So we're going to, hit the run button here. Our agent core logic will be executing and we'll see very rapidly we get a return for one flight found. For our outbound, we have another flight that's found for our inbound. We've got 2 different hotel options. In this simple agent that we've built, we've just gone ahead and booked that, and then we're sending the email confirmation. And then coming back after all of that agent logic has been processed and that agent loop has been completed, we get our complete response back from our LLM. And again, just to reiterate, we're built on top of Anthropic with this particular agent. So here's Anthropic returning with our full itinerary for our trip. So this is our sunny day scenario, right? Everything is going fine. We can come into WireMock, make sure that it actually is the one servicing these requests. So let's go into the flights. Let's take a look at our request log. And sure enough, we can see that we have our two calls that came in just a few moments ago servicing this agent loop. Right. That's the easy path. That's the sunny day scenario. That's great. But again, where we really need to have all the variables in control is worrying about those edge cases and rainy day scenarios to ensure that the LLM doesn't get itself into a bad state with the aid of our agent logic. So let's use WireMock Cloud, as many have done in the past, to introduce some chaos. In this case, let's open up our payments mock API, and let's, using the chaos module, introduce some 402 errors. So we're going to go 402, and just so we can make this happen 100% of the time, I'm going to enable chaos at 100% and just have it return a 402 here. We're going to hit save. Come back over into our travel booking agent, and we can either rerun the same prompt. Let's just go ahead and do that. I'm going to go ahead and hit run again here. And now we can observe exactly what might happen. So we can see that we were able to search the flights. We found one flight, again, going and coming, searching the hotels. And now it seems like we're taking a little bit more time, right, in the processing payment. Ultimately, receiving this processing payment, we've got this non-user friendly error message coming back right now, expecting value line 1, column 1. This might confuse those end users, so definitely an area for improvement on this negative scenario. But then we can also see, how did the Anthropic LLM process this condition? Is it the desired behavior? So we can see it, I'm sorry, the payment processor returned an unexpected error. Payment wasn't completed. Here's where things stand. The flights and the hotel options were successfully found, but we were unable to complete the payment for those. And what it recommends, try doing it again in a few minutes, or if it's failing, contact your bank or support team to investigate. So pretty nice result here. Might be, some things that we want to improve upon, maybe especially around this error message here. But, very quickly, very easily, again, all of the variables are in our control because of this clean room testing during agent development. Let's again now turn off our chaos here and explore one more possibility, maybe adding some latency into one of our mock APIs. This time, let's go over into our flights mock API, and we'll use chaos mode again for here. Let's go ahead and just say that we are going to fix the response time for all of our API calls to be, let's go 15 seconds. Sounds like a long time, maybe on a day this is struggling at the point, but we've got our 15-second delay. And now we can go ahead and run our process again. And hopefully those of you using, WireMock Cloud quite often will, notice that this didn't actually work the way that I had posed that I intended it to work. So that's we'll have to investigate exactly where did I go wrong here. So we can see that our flight came back very quickly, and we're back to our sunny day scenario. So I make mistakes too. Let's go ahead and come over into our stubs and just take a look and see down at the bottom of our mock API here. This is our travel agent flights. Let's set it over here for 1500 milliseconds instead and save it here. Verify that change is in place. Looks like it is. Let's try one more time. Could be a caching issue that we're seeing here, where it just took the same cache. Now we can see that cache has been busted. and we're searching for that first outbound flight, and it's taking time. All right. And we can see that our agent in our agent code, we have a 10-second hard limit on how long an API needs to return. And we can see that both the outbound and the inbound are failing because it's taking longer than that 10-second configuration in our agent logic. And we can come down again and observe, hey, has our LLM integration, our agent code working together with the LLM that it's built on top of, is it working in a way that is satisfactory when this edge case or error scenario happens? And you can make that determination very quickly. Again, emphasizing that the world is your oyster. You can now test all of those edge cases and those rainy day scenarios in addition to your sunny day scenarios. And you can do this at incredible repetition without worrying about bumping into third-party API constraints or consuming too many calls or getting rate limited. And if you were even to virtualize out the Anthropic API, you wouldn't even have to worry about your token consumption either. All right, let's go ahead and kind of put this back to where we were with no delay. We just want to get through our tests as rapidly as possible right now. So I'll just make sure that my chaos is also turned to no delay over here. All right, so we should be good to go. Back to our sunny day scenario. So let me just flip back real quick here. Right, so this is kind of what we just covered, where we injected failures on demand thanks to this clean room, right? We have as many variables in control as we possibly can. I like to equate this to the scientific method to testing enterprise software, where we try and just change one thing at a time or as few variables as possible at a time so that we understand exactly what our little change in the code actually has an effect upon the outcome or not. The last piece or two pieces I want to talk about today is kind of how does this fit into testing, right? We'll see that yes, we can do CI/CD testing, as many of you are aware, and this makes a lot of sense in this world as well with CI/CD testing. Again, making a small code change, checking in that code, keeping as many variables constant in that clean room as possible. Therefore, we're testing the code change and we're not testing how is the upstream API behaving today. It's all about our code. This other concept, though, evals, right, is very large and very popular inside of the agent and agentic coding world. Evals are a way of testing our behavior of our agents coupled with the behavior of the LLM and helping us to create test cases that will allow us to make a decision on whether or not we should promote or not. Lots of other uses for evals, even using them in production is a capability, but we're talking about them more in the sense today of using evals inside of this clean room, right? So structured test cases that assert on the agent behavior. It's just not, hey, did it run? But did it actually say the right thing? Did it follow some type of policy that we've put into place in the agent? Did it actually increase the number of tokens that are being consumed or decrease the number of tokens being consumed upon this latest iteration of our agent code, right? Because agents are non-deterministic, right? We need this eval-based approach to really measure a signal over many, many, many runs, because that LLM might return a slightly different set of verbiage every time we send the same request into our agent on the front end. And like I said, it's going to help us drive those release decisions. So let's go ahead and actually kind of take this and see what this looks like inside of the code here. So I've got a little feature flag here, token optimization feature flag. This latest code that I'm checking in or I want to test is targeted at spending less tokens every time that a user submits a request into our agent. So what I can do here is I can say compare our variants right now. And this is just a helpful little inlay into the application. Traditionally, you wouldn't have this panel inside of your customer-facing agent code. But what this is doing right now is it's testing our baseline variant, meaning before we make this code change for token optimization, go ahead and run through all of my eval test cases. And this is, one way of reporting out natural language itinerary request. And we can see that that's testing end-to-end booking from a conversational user request with a city preference. That's a little bit different than a test case that is a structured value focused, where the user might be asking the agent for finding the most cheapest or the cheapest route, right? Different ways a user could ask the same type of question, resulting in maybe the same queries, but the user is going to ask it different, and the LLM might report back differently. So now that this is done running, it's run our 3 different evals. Of course, you'd probably have a lot more. And it's reporting out some metadata on here as well. And then we can see it switches over to using the token optimized variant. So now it's going to run a slightly different version of the agent code prompt that gets sent to Anthropic's LLM, trying to observe whether or not do we still pass all of the functional evaluations, but also drive down the cost of each one of these invocations. So we can see these numbers all being reported here. And in the top right of my screen, you'll be able to see that we're actually comparing the eval delta between the feature flag being turned off and the token optimization feature flag being turned on. We can see that our token utilization, those tokens, that's how we get charged by the LLM, has decreased with our optimization code in place. It even decreased our cost delta more than just the token delta. And it actually sped up our interactions with the LLM as well. So given all of this, for every 10,000 invocations, we're going to save $10. Sounds pretty good for me on the bottom line. And we get that decision to promote this variant to the next stage of our CI/CD pipeline, as this is a recommendation that this is a valuable change for us. All right, so that's kind of what I wanted to show you today. Of course, as I said, we could run CI/CD tests as well, kind of the same style of approach here, either using our evals in the CI/CD process or not. But another great place, right, to make sure, again, as we check in code changes, if it's a token optimization change, maybe it's a new error message for when that payment processor failed, to make it a nicer experience for the user, that we always want to be able to test these things, these small changes in a clean room, in a vacuum, using that scientific method. And I'll wrap it up on this slide here before we move into questions, right? Really, the scientific method for agent testing. Isolate one variable at a time, and that should be your agent code. Everything else, the APIs, the LLM, the latency, right, can all be fixed in WireMock. When we move on to that eval strategy, right? Maybe we don't want to virtualize or stub out the LLM anymore, because we really want those evals to test the conjecture, the integration of our agent-based code, and how the LLM responds many, 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 many times over to ensure we get pass rates on those evals. We don't have environment noise between these runs because we're controlling all the variables, and we're minimizing how much infrastructure we need actually to run these agent test cases here. We can then compare each one of these variants in a like-for-like environment, again, controlling as many variables as possible. And it helps us make those data-driven release decisions more easily when we control as much as possible. So with that, I am going to kill my screen here, and we'll see if there are any questions that popped up during today's session.
Yeah, great presentation, Dan. Thank you. And we do have a few questions. So Alona just asked and maybe joined us a little bit late and missed the beginning. But could you reiterate how you go about getting that agent even wired up to WireMock so that you're getting that chaos, that negative test feedback?
Yeah, that's a great question. And I do believe I skipped over that. So if we come into our actual code base, right, for the travel agent, take me a second potentially to find where the endpoints are defined inside. It's probably inside of our config here. And here we go. We can see that we have our particular application that is built here is using a config file, right? So We've got a travel agent config file. It lives in our app data travel agent config.json file, so we could edit it in there. This is just like most standard enterprise applications have some type of externalized configuration file, or they're using environment variables defined in AWS secrets or the equivalent inside of Azure or GCP. And in this case, we also have a set of fallback URLs. So in case that file, that environment configuration file is missing, they've been by the developer of this agent have hard-coded fallback APIs. So we can see right here, these are those particular mock API endpoints that have been plumbed in to this agent base code. So just standard fare, just like you would for any other application in the enterprise, when you want to start using mock APIs instead of real upstream APIs, dependency APIs, you reconfigure your system under test to point them at the mock APIs. And that's exactly what we're doing here, either with the config file or, if we wanted to, hard code them via these fallback URLs, that's where we would do it in this particular agent that I showed today.
Great. And then another question that we've got, um, and I'm going to extrapolate out a little bit, but for previous sessions on AI, we've looked at a few things, right? We've looked at the CLI, we've looked at MCP, we've looked at the WireMock runner a little bit. Can you kind of summarize how these different pieces snap together in the context of what you just showed?
Yeah, yeah, sure. So, AI, right? Big buzzword today, right? Many users start their journey with AI by installing ChatGPT or Claude, and they use it a lot like they did Google. They ask it a question, right? And they kind of go from there. The next iteration on top of that is asking for more detailed guidance, right? I need to build a simple application to help me track my to-do list because I don't like anything that's out there on the market today, right? That's probably maybe someone's next journey into AI. But enterprises are now looking at how can we actually build AI into our offerings. So think about going to a company like booking.com, right? And instead of, going into the search box the traditional way of I want to go to Paris, just being able to say, I want to go to Paris and I want to stay in this area, and this is the time frame I want to go on, and I want to optimize for price, or I want to optimize for these specific days, or I want to optimize the best class and best price in business class because I want to treat myself, right? Try doing that today in most enterprise applications. That's going to be difficult. A lot of button clicking. You got to be a power user to figure out how to do that. These agents, like the one I showed you today, open up this world of possibilities to enterprises to, you know, have these offerings, to work more conversationally, as if you were talking to a real travel agent on the phone. You're talking to a combination of agent logic, as I showed you today with our booking agent, talking to APIs and doing that work for you, coupled with the Anthropic and the LLM. Now, the other sessions we've done with WireMock and AI, right? That kind of falls into that second category or third category that I was talking about, is where we are trying to at WireMock make the experience quicker, easier, simpler, more powerful using AI. And today that we've made that available via our MCP server that you install into tools like Claude and Claude Code, Claude's CLI, Claude.ai on the UI if you wanted to. Open API, you name it, right? They all support those MCP servers along with our skills, which are a set of best practices and detailed directives for the LLMs to say, hey, if a user wants to make a mock API that is static into something that is stateful and dynamic, what's the best process of doing that? What steps should the LLM do? That's what our skills do with WireMock Cloud. So it's shifting from having to do a lot of pointing and clicking, making API calls, building scripts yourself, to working with your existing coding assistant that you're using today and asking for exactly what you want and allowing the LLM coupled with our skills and our MCP server to get that work done again more efficiently, more effectively, and even more production like as we've seen with the skill sets. Does that answer the question?
Yeah,
Wait.
perfect. And I think we got one more, and then we will wrap it up and let folks go. Again, we will be sending out the recording. And I want to reiterate if you have any additional follow-up, if you're interested in a one-on-one session with your team, digging any deeper with us, just reach out. We are happy to do that. You can do Dan at wiremock.io or Ethan at wiremock.io or sales at wiremock.io, whatever you prefer. So the last question we got here is the functionality only available in the cloud, or is it also available in a standalone version? That's a good question, right? Because we can talk about the runner and different ways to use it in higher sensitivity environments.
Sure, you want me to take it, Ethan?
Yeah, go for it.
Yeah. So yeah, what I've showed you today, right? And I'll be completely honest with you. You could do today with most of it, a lot of it you could do with open source, right? When you look at chaos mode, where we're going to randomly inject faults and failures, that is a WireMock cloud capability only. So you wouldn't be able to have that chaos mode in there. Some of the stateful behavior that might be important to your mock APIs, right? I just showed you that process today of, okay, we use the agent to try to book some travel arrangements, but what happens if I want to go back to that agent and make a modification, or I want to delete my existing reservation and get a refund? Our mock APIs have to be stateful and understand what is my past reservation that I made so that I can modify it or that I can cancel it. That statefulness is something that is only available in WireMock Cloud and not in WireMock open source. Now, for those that are security minded, WireMock Cloud has a couple of different ways to work in even the most secure environments, like we do with our customers. So while by default WireMock Cloud is fully hosted SaaS, and you have dedicated infrastructure in our AWS account, you can run in a hybrid mode. Hybrid mode meaning you install what we call the WireMock runner or WireMock CLI inside of your private network. And it pulls down configuration sets from your WireMock cloud account so that you can run your mock APIs completely behind your firewall, where none of the traffic you're sending to it or the responses that it's generated ever leave the confines of your private network. And that is typically the approach that the majority of our most sensitive customers use. Now, for the most ultra conservative environments, we also do offer WireMock Cloud in a Kubernetes edition, which is a one-for-one match of our fully hosted SaaS offering, but you host it inside of your own Kubernetes cluster. That way, it can be completely air-gapped from the outside world. You have a one-for-one feature parity with what we offer in WireMock Cloud. And then you have the ultimate in security, where nothing ever leaves or is stored outside of your private Kubernetes cluster.
And all of that we would be more than happy to discuss with you in more detail if you want to reach out. So don't hesitate. And that will do it for questions. So we'll get you the email after the fact. We'll let you know in a couple weeks what the next session here will be about. Hopefully, we hear from you with some follow up. And thank you again for joining us today. Have a great rest of your day.
Thanks all.